Okay, so if we want to verify this identity, we need to figure out the t hat and the n hat. So remember the definition of t hat of t. It's the principal unit tangent vector. That's the direction you're going. So we're going to take the velocity and divide that by its magnitude, the speed. And we have each of these from before. The speed is square root 5. And the velocity is 2 cosine 2t, 1 negative 2 sine 2t. The way we multiply a real number times a vector is we multiply that real number times each of the components. So if you do that and rationalize, I'm going to get 2 radical 5 over 5 cosine 2t, or radical 5 over 5, negative 2 radical 5 over 5 sine of 2t. Okay, so there's our t hat again, and now we need n hat. N hat is the direction we're turning. So we're going to take the derivative t hat prime of t, which is the rate of change of your direction, and then to make that a unit vector, we're going to have to divide that by its length, like that. So what is t hat prime of t? We need that first and foremost. I'm going to have negative 4 square root 5 over 5 sine of 2t. The derivative of that is 0. The derivative of that is negative 4 square root 5 over 5 cosine 2t. Now for the magnitude of t hat prime of t, you might be able to spot right off that since we've got a 0 here in this component, as before, we're going to get a sine squared and a cosine squared, and then we're going to have Pythagorean magic happen. So you might be able to spot what this is going to be right away, but we'll go through the machinations here. If I square this, I'm going to get 16 times 5 over 25, which is 80 over 25, sine squared 2t, 0 squared of course is 0, and then 80 over 25 cosine squared of 2t, all underneath that radical. Sine squared of an angle plus cosine squared of an angle equals 1. So Pythagorean magic does happen. I get square root 80 over 25. And that simplifies to 4 square root 5 over 5, which is the coefficient, the absolute value of the coefficient there of the sines and the cosines. So you put this all together to get n hat of t. It's 1 over, so it's the reciprocal of this, which is going to be 5 over 4 square root 5 times this, negative 4 square root 5 over 5 sine 2t, comma 0, negative 4 square root 5 over 5 cosine 2t. And once again, we take this real number times each component. I get negative sine 2t, 0 cosine 2t. All right, so that's n hat. Okay, so now it's time for the grand finale, the big payoff. Here's t hat prime of t. 2 radical 5 over 5 cosine 2t, comma 1, negative 2 radical 5 over 5 sine of 2t. It really doesn't matter what this is, because if you notice in our formula here, we're going to multiply that by our tangential component of acceleration at, and at is, of course, as we found earlier, 0. Then here's our n hat, negative sine 2t, comma 0, comma negative cosine 2t. So on the last slide there, I had forgotten my negative, but there it is there, so that's what that's supposed to be. We're going to take this vector and multiply it by our normal component of acceleration 4. And when I do that and add them together, I should get my a, which is that, which we had before. So let's check that out. AT hat plus AN hat. We mentioned before AT is 0. 0 times any vector is the 0 vector. Plus 4 times this vector. Is that in fact equal to our vector a of t? And you can see right away that it is. We multiply each component by 4. We get negative 4 sine 2t, 0, negative 4 cosine 2t, which is exactly what we get for a of t. So once again, in the case of a helix like this, all of the acceleration is in the normal direction. Okay. And what's nice about a helix is that you can actually get at all these things without doing a horrendous amount of Calc 1 and algebra to do it. So that'll do it then for checkpoint quiz 3.